even started practicing the system design questions. So microservices, micro questions we have been solving, and now we are continue with our leftover questions and moving forward with the next question. We're just checking the mic. So yeah, it's working fine. Now let's move forward. So we are rather than moving forward with the manipulations and architecture, event architecture, we will be more focused on uh, system design. Let's move focus focus on system design and master it after master it with a few questions. After that, we will mm, we will go with real world small projects. Okay, let's start some micro question. Let's start from some basic to advanced system design question. So hello everyone, well, we are back again and practicing the system design questions. Let's master the system design because it's the most important concept that we have. To master the system design using the object-oriented JavaScript, you need to understand how professional backend manage high throughput operations in production system. Data does not move from point A to point B. It gets cached, queued, and throttled to prevent resources crashes. Okay. Here is a next high velocity system design roadmap. We will progress from level 1 memory cache engine to up to level 3 distribute message broker. Okay, let's start with the level 1. So least recently used the cache engine. Okay, curing the problem is curing a database takes times to speed things up. Apps store frequently requested data in memory like Redis. However, server RAM is limited. If you cache everything, the server run out of memory. And cache solves this by keeping a fixed size. Example, max 3 items. When the cache files up and a new item arrives, it automatically drops the item that hasn't been accessed for the longest time. Okay. Task, let's build class LRU caching. Okay, we have a class cache using JavaScript map architecture. Okay, let's see the let's create a constructor, and we have created a constructor. In that we have a capacity. Got it. uh, this dot capacity equals to capacity. Yeah. After that, we are also having a private variable. Let's create a private variable which is cache. So cache. Okay, a cache, a native JavaScript map object. uh Cache, a native JavaScript mapped object. Okay, we have a public method too. Mhm. Let's create a public method that is a get, okay, key. If the key exists, return its value. Crucial system rules. Reading a key makes a recently used. In a JavaScript map, you updated it recency by deleting the key and immediately setting it back. This dot hashtag cache, this dot delete key. Okay, this dot cache set. Okay, this is little bit tricky and complicated. Let's just understand what does it mean. Just a second, little brightness full. Okay. So what we have, public method get key, put key and value. System design goal is balance data access with the strict hardware and memory boundaries. Okay. If a key exists, okay, return it value. Got it. We got a first statement. If a key exists, it returns it value. Crucial system rule is reading a key make it recently used. In a JavaScript map, you update its recency by deleting the key and immediately setting it back. This dot hash cache dot delete key. This dot cache dot set key value. If does not exist, then return -1. It's little confusing, yeah. Actually, it's a high level questions also. Because we didn't practice like this types of questions. These are new to us also. So let's see and understand how does these things are working. The first value is if key is existing, then which means if key has a value, is if it has a something value, then it will be just a return its value, return key. Uh, Here we have a native JavaScript object. Okay, so let's create a new map here. So I think map we are creating a JavaScript native map like this map object, and we will check. Uh, it's still confusing actually. Public method. If the key exists, return its value. Okay. Uh, okay. So what we are doing is if map dot has key, then return map dot get the value of key. Okay. So like this, we are working with map. After that, what it is, if a JavaScript map, you update its regency by deleting the key. First of all, we didn't understand this thing. Let's just uh, understand the statement. Okay. Explain me this sentence in ELI file. Let's understand the what the sentence means. Actually, we didn't understand the what does the sentence actually. In the JavaScript maps, keep items in exact order you add them because the map only allows unique keys. Removing an old key, okay, that's we are know. Think of a stack paper, okay, we know. But what does this sentence means? What does this sentence means? Explain explain in a life file and in concise response. What is the sentence? Yeah, this is the sentence. Okay, so let's just understand. Imagine a line of kids waiting for the lunch. Okay, JavaScript maps remember the order kids stand in line. The last kid in the line is the newest. Okay, to make a kid the newest, most recent. Okay, so we have to, what do we have to do? The last kid line in the kid is the newest. Delete, you tell the kid to leave the line. Okay, set, you tell them to go to the very back of the line. Okay, uh, okay, someone has broken the line and last kid is the last kid in the line is the newest. Imagine a line of a kids waiting for a lunch. The JavaScript remember the order kids stand in line. The last kid, okay, the last kid in the line is the newest. Okay, to make the to make a kid the newest, which means most recent. Delete. You tell that kid to leave the line and set them to go the very back of the line. Okay. Okay. Understood. Little. Let's just understand how this we can do. Uh, this dot catch is a map, right? Dot delete key and dot set. Map dot set dot set equals to key and value. Okay, so it will be returned. And the JavaScript map, you update rinse and deleting the immediately key back. Okay, so what will you do? This dot hashtag catch dot delete. We will be deleting the key. After that, we will be do this dot hashtag catch dot set. If you don't know about this thing, this is a native JavaScript map. You have a map method also in a JavaScript to run the loop or something to operations. But this is a map data structure. In that, it's like a similar like to object, but it's hold a key value. Okay, so we have a map data structure, and this is a JavaScript native map object. Okay, so here we set the map dot set needs two parameter. One is key and other is value. And key dot value. Okay. If does not exist, if does not exist, then return -1. If map dot has key, then it will be do like this. Else, if I do else, if it is written, then if it is not, then what we have to do is we have to delete first of all, right? So this is a map dot delete. We will be deleting the key. Okay. After that, what we will do is map dot key. But we didn't get a value here, right? From where we are getting a value? Returns its value crucial system. If it is has a key, if the key doesn't exist, what we will do? Let's say we have a key, right? Deleting the key. If you have updated residency by deleting the key and immediately setting it back. This dot cache delete key. Uh, 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 uh. Okay, let me check. Okay, let me check. Let me check. Okay, okay, okay. We are don't deleting this thing. We are just modifying this thing. So here, if map has key, then what do we do? We will be return, but before return, if the keys exist, return its value. Okay. If does not, then return -1. Okay. Else return -1. Okay. So what we will do? So not return like this first of all. Let's comment it. We will be doing this dot hashtag cache dot delete the queue. Okay, we'll be doing this thing first. After that, we will be if it is has, which means if map dot has key, then we have to do is if map dot has key. If it is has key, let's store it answer. Let ens equals to map dot key. So it will be get a value here, right? So let's take a value name. Okay, so it will be take the value here. Let's a value, and after that we will be delete map dot delete key. After that, this we will be set the key and value together, and at last we will be return the value, right? So done, I think so. That's it for the questions it's need. After that, we also have just a second comment. Yeah, back again. So let's just move forward. We have another thing. Method, public method is put. Okay, so let's understand what does put here. So in the put, we have a key value. In that, adds the key value pair to the cache. If the okay, we have to add it. Got it. If the key already exists, so first we will check if map is what is the map here. Map is okay. We didn't have a map, right? This dot hashtag cache is the map. Okay, so here also this dot hashtag cache. Okay, cache dot get. And what we will say is if this dot cache see cache, if this dot cache dot has, if this has the key, then what we have to do, update its value and refresh its position. Okay, uh, refresh its position. If map dot has key, which means if it is there, then it will be show true. If it is true, then what we have to do, update the value and refresh its positions. Okay, let's do. Then we will be doing is map, which means this dot cache dot set. uh, what will you set? First of all, key comma value. It's a update, it's a key and it's a value also. Map key is 4, value. Update its value and refresh its positions. Okay, I don't think so. This little bit confused about it. If the key already exists, update its value and refresh its position. We have to update its value, so which means uh, it will be having like the key exists map dot set key and value. Okay, if the cache hits its capacity limit, okay, it has a capacity also. Okay, we didn't understand the questions, I think so. Class using the architecture. Okay. Uh, Querying a database takes time to speed things up. Apps store frequently requested data in memory, like Redis. However, server RAM is limited. If you cache everything, the server outs of memory, and LRU cache solves this by keeping a fixed size. Example max 3. When the cache fills up and a new item arrives, it automatically drops the item that hasn't been accessed for a long time. Okay, got it. Okay, so we have a constructor example. Accept a constructor capacity which has a okay 3. Let's go up line by line and understand this thing. Let L1 equals to new LRU cache. Okay, yeah, you have a 3 capacity, which means this has a capacity 3. Which means we have to pass the size also 3 something. Mm, New map. We have to fix the max capacity is 3. Okay. So how we are going to set is max item 3. So we have to check. This is a get value, right? So here put. First we will be check. Oh, sorry. No, yeah. First we will be checking here if the this dot hashtag cache dot size map dot size, yeah, this dot size. uh just a second. Console dot log let map map equals to new map. uh map dot size is a method or a property? Let's just say 0. Okay, it is a property. So we will be using the map dot size is equals to this dot capacity. If it is a 3, then it will be showing the 3, right? If it is 3, then this dot capacity will show. If is this equals to this dot capacity, not equals to, if it is less than equals to, not greater than, isn't should be less than equals to, less than equals to uh if it is less or equals to, less than equals to this dot capacity, then we have to do like this thing. Okay, let's okay, we have been done this dot capacity. If this dot cache dot has a key, then it will be like this dot cache dot set is equals to key and value. Okay, apart from this, if the key already exists, if it is exist, then it will be, the key is exist, then it will be what it will be do is here, if the capacity as the, if it is less than equals to capacity, then we will be do update. If the capacity limit is hit, evict the oldest item, which is always the first key in the map. Okay, a little bit confusing here, but we are understanding and we will be solving it. What it is about, if the cache hits a capacity, let's check if the cache is greater than, let's comment it out for now. If the cache hits its capacity, which is capacity is greater than, if it's greater than hit, it will be 0 from start. If it is uh, capacity is 3, yeah, let's be greater than equals to hit. If it is greater than equals to capacity, then what we have to do? What we have to do? Then evict the oldest item. Evict the oldest item. If cache size dot capacity. What? I'm a little bit confused here. Mm, how do we are evicting? Which means we have to update. If the cache size hit its capacity, evicts the oldest item, which is always the first key. First key in the map, this dot cache dot keys dot next dot value. Oh. Before adding the new item, it's confusing here because uh, but little bit confused. What we have to do is add the key value pair to the cache. If the cache is already exist, update its value and refresh its positions. Okay, refresh its position if the already exist. So what we are doing, this is thing. Okay, let's cut from here and let's from here. So we are practicing a system design question, and that we are try to work as a Redis, as a what does the Redis do? Cache do. In short, cache do. When you hit a capacity, so it can't store all the things like full database thing. It can store the some of the elements, some of the data in this cache, but you can't store all the things. So if it is overloaded, then it will be just erase the last one and update the latest one. Okay, so like that we are doing here. So let's just see, adds the key value pair to the cache. Okay, we are adding, put in the put element, it adds the key value pair. So this dot cache if has, if the key already exists, update the value and refresh its position. Okay, so it's just refresh, else what it will be do, this dot hashtag cache dot set key comma value. If it is already has, so it will be key, and just we have to add on little bit confused how it's update its value and refresh its position. Its positions will be changed. The position is set by the key, right? If it is has map dot has, let's just understand. This is a map, right? Okay, we are having a map here, and this is, let's assume, one. After that, like map, this is a map syntax, and it's a value of a. Okay, after that it has a 2, it has a value of b, so it's like this. So just assume we have added here 3 and 4. If map, this is a cache, okay. This cache is representing the map dot has key, so we have passed the value here as a here as a key 3 comma 3, and its value is c. Okay, it's 3 and c. So how we are going to do is 3 and c. So it was set map dot has 3. Does it has 3? No. If let's assume if it also has a 3 here. Okay, it has a 3 here. 3, let's, it has a e, right? So it, we have to update in c. So map dot has 3, yeah. So map dot set key, and here it will be update, like directly we are updating the value, so it will be just change the value, right? Okay, it's just updating the value because they are also same, we are not modifying the value. Okay, let's assume we are going correct. Let's hit and try and understand what we will be facing issue. After this, if the cache hits its capacity limit, we will check if the cache is greater than or equal to the capacity. If it is so, then evict the oldest item. Little bit confused, but evict, I think so. It means remove the. Uh, what does this sentence means? Means. It's happened with me all the time because I sometimes, or most of the times, I didn't understand what does this sentence means. So does with happens with you. So share with your experience in the comment section. So to evict the oldest item means to kick off. Okay. Uh, Done. We have to kick off the very first thing you have put into the list because you ran out of room. Okay. Yeah. We have to just remove the first thing. Okay. If it is like this, if it is capacity is greater than equals to this dot capacity, then what we will be doing is removing the first thing. This dot hashtag cache, uh, which is always the first thing. This dot cache dot keys dot next dot value. What is next dot value means? This is a map dot keys dot next dot value before adding a new item. Okay, we have to do is before adding a new item. Okay, let's just understand the meaning of this thing. Uh, and what, and decode this, assume cache is a map data structure. Sure. So we are analyzing this. Okay, so storage of the map. So the keys get all the list of the item inside and inside in the key order where they added. Okay. Next, this grabs the very first item in the front of that list. Okay. Value reveals the actual name, the key of that first item. Okay, okay, okay. So the dot keys method helps to get all the item from the data structure, and after that, dot next grabs the first item, and okay, got it. So yeah, like this we are understanding and helping, taking a help from the AI to understand this of the concept, because this also also a new concept for me also, because I didn't practice too much in depth in the JavaScript. So here we are practicing the depth of the JavaScript, understanding how the real world system design works, and so that we can crack our jobs, crack our most crucial things that we want to learn. Okay, so stay with me so we together master this. Okay, so if you are new to this channel, so like, share, and subscribe, and stay together, and also share your questions and your things that you are doing with, and we can together do this together and grow together. So let's just see. We have to first of all check, okay, before adding anything. So I think we should do this thing first of all. Okay, so here we are doing if the capacity is greater than equals to this dot capacity. If it is greater than equals to capacity, then what we have to do is this dot cache dot keys dot this keys dot next, okay, next dot value. So what will it do? uh, in short, it targets the first kid in your line so you can evade them. Okay, we got the value right. So let first equals to, so we have stored the first value, first okay, equals to, got the value. After that what we will do, we will be mm, 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 mm. we have to delete. It's like evac means may delete. If it is greater than equals to, then what we will do, we will first get the value. After that we will be this dot hashtag cache dot delete key delete key, and then we are going to do this thing. After that we will be do this. Okay, so here let's cut this off first of all, and cache dot set. Okay, set this is the value of this thing. Okay, and if it is not so, okay, let's clear this. If it's working, else what we will do, else we will get what we have to do is else here, see, add if the key value pair to cache, if the key already exists. Okay, now we can see else. In the else part also we will check if this dot cache dot has key, which is if it is true, then we will be setting the value same it is. mm, if the key and value already has its value, then refresh its points if the cache hits the capacity. I think so. You did directly. We will be doing this thing. Don't revert, because all the same thing we will be doing. Nothing much, I think so. Else it will be directly set the value. Okay. Okay. So we have been completed. Let's check now how we are going to check. Does we have anything test cases here? Okay, no. So directly we have to test cases, right? Uh, to remove this thing first of all. This was for our just understanding. We have created a cache which map which has a capacity of 3. mm, this we can do is like this. Let's just check. Let map equals to new map, and it is 3 event passes. Console.log map dot size. Does it say size of 3? No, 3 is not iterable. Okay, dot size equals to 3. then that it is no, dot size. Uh, can we let's just ask, can we create map for data structure sure with the height with the uh, predefined defined length. This X no JavaScript map cannot be created with a fixed predefined length, but we can create okay. Uh, 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 yeah, this is actually custom. We have a solution, but we will be not saying this because we are solving that. Okay. Again, let's assume from let's see what we will be doing is correct or wrong. Let's hit it. Okay, so we have been created, and now let's just see L1 dot get key. The key access return the value of our we will be put. Okay, put. Let's put the value is 1 comma a L1 dot put 2 comma b L1 dot put 3 comma e. Okay, and now let's just console.log get L1 dot get uh, 1. Okay, let's just check a. Okay, we got the proper value. Let's just copy and 3. So now it will be E1 and A on E. Okay, so after that we are just doing L1 dot put put we will be doing the 3 but this time with C. Okay, and now we are doing console.log L1 dot get 3. Okay, let's just see. So we are getting 3. Yeah, actually when it hits the its capacity, it just replace with original. So again we can see if okay L1 3 and now 3 you can see. Okay, I need just a second. Console.log after change. Okay, now you can see the proper after change. We can see first it was A and E, after that it just updated C. So it's a work like a cache. It's storing, it's a limited capacity. And here again we can also try uh, x cross the limit. Let's just see what will happen after the cross limit. Console.log l that get 4. First we will be doing console.log L1 not on why would we console.log. We are just checking L1 dot put 4 comma F. Okay, so we are getting, and I also want to see console.log L1. So L1 is the capacity of a 3, but I don't want L1. I want to see L1. Can we access this private limit? I don't think so. We can't access because it's a private thing. But we can see the map C. We create a C method which helps to access return this dot hashtag cache. So we just created this dot cache for dot C. Okay. So now you can see it's a 1, 2, 3, 4. Should not store like this because mm, 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 I think we left something because it's storing a value. It should not stored. If this dot size is equals to this dot capacity, uh, cache dot side 0 1 2, it should be max to like 2, right? uh is equals to -1, 1 2 3 4, it's going with 4. Then this, what should I do? Mm, what is the delete keyword is doing here? Cache dot delete key, right? uh, so why didn't it delete the key? Delete key and then set the value. Mm, okay. I forgot to delete the first actually. So because of that, we are didn't getting the delete. Let's now see 1 2. Okay, I'm just trying. I added the extra -1, right? Yeah, now it will be working fine. You can see 1 2 3. You see the first oldest one, which was actually it doesn't follow the sequence, so it's deleted the second one as a first value, which is got. Okay, I think that can create a problematic because it doesn't understand the first value. Because the map data structure is also not storing the value in the sequence, it's a randomly. Mm, okay, but we have completed the question. That's a thing. Okay, so we will be also checking the modified version, what is the optimized way to implement this. Let's moving forward with the next question. Okay, which is uh-huh. So we have completed level 1. Let's go to the level 2. So level 2 questions. So we are practicing the system design questions, and let's just understand. Okay, just explain. So yeah, let's get back to and understand how it's going to for the second question. Okay. Mm, let's just understand. Okay. So if you're watching till now, comment yeah, watching. So we also stay motivated and practice together. So yeah, let's continue. We have to practice and we have to become best version. Okay, so what is the problem? The problem of our previous rate limiter checked the exact time difference. Our previous rate limiter checked the exact time difference between two requests. While that works, it cannot handle the traffic burst. Okay, the real world API like Stripe uses token bucket algorithm. Okay, so here we learn a new thing that Stripe uses a token bucket algorithm. Imagine a bucket that holds a maximum of token. Every second, a new token drops into the bucket. Each incoming user request consume one token. If the bucket is empty, the request is blocked. The user allows to user use this allows a user to send 5 queries instantly. If a quick burst, then limits them to exactly one request per second once the burst capacity is exhausted. Okay, these are the real world programs, which is actually next level thing. Yes, this question also, previous one also is a, yeah, really a little extraordinary and surprise element. Let's follow second questions. Okay, token bucket rate limiter. We have a token bucket limiter. Let's have a class, created a class. In that we have a constructor. So, okay, constructor. It accepts a max token. Okay, max tokens, bucket capacity, and it accepts a max tokens and refill. It has a two parameter, refill rate, not paid. It's a refill rate per second. Accepting this two thing. Okay, so okay, store it. Okay, max tokens. Okay, this dot rate refill rate per second. It has a refill rate per second. Okay, done. After this, what we will be doing is private. Okay, it has some private variable. Let's create the private variable first. Tokens. Okay, done. After that, it has a max token. Okay, these are the okay. We have to do little bit changes one more time. Max token. It has a refill rate also. Refill rate and the last refill rate also. Last refill time stamp. Okay, this dot max, this dot refill rate. Okay, so understood. But in the constructor we are only getting the two things, which is max token and refill rate per second. Okay. Which is refill rate per second will be something. Let's have a public method async allow request. We have a async allow request. In that we have calculate how many tokens should be added based on the time elapsed since last refill time using date.now. Calculate how many tokens used to calculate how many tokens should be added based on the time eclipse since last refill time using date.now formula. These are the things actually creates the confusions because we didn't practice so much about this. Let's try, give a try. Okay, just a second, taking a sip of water. You can also take a hydration break. Yes, yeah, back again. So let's understand what is this concept means and how we can figure it out. So, okay, this is a thread that we are following, but now we are here created a class using the timestamp math class and build a class token class using a timestamp math. Okay, let's just understand first the question requirement and then proceed because it's little bit more confusing than the previous one that we have been solved. Okay, let's just check. Created the private variables, done. Constructor, done. Public method async allow request. The system design goal is smooth out erratic traffic spikes without completely blocking natural short burst user behavior. Uh, too much complicate. Yeah, but no issue. Let's just break it down and understand how we can do it. Calculate how many tokens should be added based on the time elapsed since last refill using date dot now. Okay, last refill times time. Uh, Formula is token to add eclipse second multiply by refill rate. Update tokens. Okay, it's a little bit complicated, right? Mm. First is calculate how many tokens should be added based on time. This is the question. Okay. Since last refill time using date of 9. Okay. This dot last refill time stamp equals to uh, date dot now. Okay. Date dot now is the last refill timestamp done. Apart from this is formula tokens to add equals to eclipsed second. Okay, formula is tokens to add. Let's create a const tokens to add here. Okay, here we have eclipse second. Eclipsed since okay, fill rate will be okay. Eclipse second I think so. This is a this will be using here. Okay, by mistakenly my hashtag is gone here. We have to use hashtag here, right? Let's go with the flow and understand how we can manage it and multiply by this dot hashtag refill rate rate. Okay, this is the thing that we have been concluded by our understanding. Got it. After that, what we have to do is update hashtag tokens. Mm, this dot hashtag tokens equals to math dot min hashtag max tokens comma uh, hashtag tokens plus tokens is this dot tokens and max token is this dot max tokens and it will be added with the tokens to add. Okay, yep, we follow the instructions. Okay, currently we have been given some certain tasks of instructions and we are following that. But after this of solving we will be getting a statement because most of the companies interviews while in the problem solving statement they are given is they are giving certain kind of a textual context and reading those contexts we have to figure it out what we have to do what is the problem statement. They didn't provide us like this kind of a requirement and steps. They just give the test cases to testing it and give the sentences of question. So we have to prepare like that that kind of a stuff that we understand. Okay, so let's move forward. We are calculated and we have updated also. Now we have to update this dot last time refills. Okay, let's just copy this and paste it and last update is equals to again date dot now update if the token is greater than equals to 1. Okay, decrement the token by 1, return true. Why they are giving the sentences in the end of the thing? Because we have to again from start begin. First we have to check if the token is greater than equals to 1, decrement token by 1 and return true. Request allow, otherwise return false. Okay, let's give it a last thing only. We'll check if this dot hashtag tokens, if this dot hashtag tokens is greater than equals to 1, then we will be do this dot hashtag tokens minus equals to 1. Okay, and okay, but we have to do like this. Okay, because this is the not of ones, and return true. Okay, after that return true, else it will be return false, rate limited. Okay, so we have been satisfied all the conditions that it asks us to. Let's just follow okay, let's just try. Let uh, t1 equals to new token. Okay, let's created a new token. In that we have to pass the max token should be, I think so, 5. For now let's say a short 3, and refill rate per second. I think so we have to use here some kind of async thing also, maybe, but they didn't mention anything, right? uh, okay, let's just give rate per second, refill rate per second is 1 for now. What we have to do is oh yeah, when we see this async, so we should give a async thing, because it's a async, right? So it will be have a certain time limit. Calculate how many tokens should be added based on. So when we have refill rate per second, what does this refill will work? We didn't use anything refill rate, right? Refill rate is here, which means we have to see is multiply by eclipse. Mm, I'm still confused about this. Let's go. Let's give a try and then see. For that, we have to use async function. Mm, I don't know. Maybe let's create a ms. Let ms equals to uh, function which has a thing, return new promise, which has a certain return new promise. Okay, set time out. Uh, let's remove this thing. So we will be getting a ms here, sec, and sec, and here we will be get what we will be get. Let's just clarify this thing because it's confusing to create a new promise. Okay, in fact a new promise is like this. It has a set timeout inside it. Okay, new promise, promise syntax way promise sy and syntax ngs. Didn't forget. Okay, similarly like this, but it has a resolve. Okay, it has a two thing, resolve and reject. Always forget. But yeah, here we have to do is set timeout here, and set timeout has a thing which is like sec. We will be getting a sec here and resolve here. Resolve. What we will resolve? Waiting. Not waiting, loading. Okay, so we have created a ms function. Ms function, we will be doing it here. I think so. Just check. Last refill date dot now. Uh, we will create like this here. Ms await ms equals to pass second of this dot hashtag refill rate. Okay, refill rate will be passed here. Okay, let's just check and now async function run. Here run is having t1 await, let response equals to await. After await we will be passing t1 dot allow request, allow request. Okay, okay, let's just see and cons dot log response run. Okay, false. Mm, 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 mm. Why it is false? And also it doesn't wait it, right? Mm, why it is false? Mm, 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 mm. Even the allow request, async allow request. I don't understand why it is false here. Let me just check. We have created token bucket limit rate limiter class. Okay, using class using timestamp map. Okay. Requirement constructor accept a max token refill rate per second. Okay. Uh, here we have a token private states, tokens, max tokens, refill rate, and last refill stamp. Okay, done. We are exactly following the things. And while in the public method, we have allow async allow request, created allow request. So after this, we have to create calculate how many tokens should be added based on the time eclipse. Okay, lessons last step timestamp using date dot now. Done, completed. Formula is okay, this multiply by eclipse second, which is this second, right? Multiply by, what does mean by eclipse second? Let's just understand what's the meaning of this word. What does this means? Is a variable name used in a program time passed measured in second. uh, Start time and end time equals to minus. Okay, does they what this means? Mm, but how does here this thing works? Last triple time using the data times. Okay, and formula. Okay, refill rate per second is 3 date dot now. Last refills. Uh, tokens dot add equals to last dot refill timestamp. Here this timestamp, and it will be minus by date dot now, right? Does it store anything for the last refill times by default? Eclipse since the last refill time using the date dot now. Formula token eclipse seconds. Okay, fill the rate limit. Refill rate limit is 3. 3 multiplied by date dot now is something. So this is the best knowledge that I have been done, and I'm not satisfied with that. Okay, let's just share our solutions and ask Google to run it, check it. Okay, let's remove this thing first of all. It has a L1 and this has a T1, right? Okay, check our solution for question 1 and question 2, and give feedback to review it concisely. Okay, so we haven't shared the questions. Let's just review. Verdict: good structure. Okay, a structure is good but has a two critical bug: the override eviction bug, data loss. Look at put 3 a logic. If the cache is full and you update an existing key, the code checks the capacity, it triggers eviction, deletes the oldest validated key, and overrides the 3. You accidentally deleted a perfectly good item during an update. Okay. Uh, the update failure bug inside the eviction blocks you run. Okay, if a key is already existed, it will update the value but not refresh its recency positions to the end. The correct put engine is okay. Let's review it. Put value this dot. Okay. Mm-hmm. It will be check. If it is, then it will be delete the position first. Okay. After that, else if it will check if this dot size is greater than equals to this dot capacity, then we will be delete the oldest key. Oh, okay. Let's fix our issue bugs. Okay, this dot the hashtag cache dot has key. If it has a key, then we will be doing is this dot uh, delete key first. Okay, so it will be refresh the position. After that, we will be do else if this dot cache dot size is uh, greater than equals to this dot capacity. Then the okay, this is the correct thing. Okay, and we will be deleting this same thing for the first. Okay, and let's remove this because in all conditions we have to do is the one thing is set the key and value. Okay, we almost corrected, but some of the major flaws which were there. And token, okay, yeah, I was this is a not good code. This is a 1 out of 10 or 1 out of 10, so it is a bad code. Time stream multiplication disaster. Yeah, it's actually a disaster. uh, let's just see how it's actually meant to be work. This is correct. Okay. Okay. Initialize full and last refrain is date dot now in the starting track only. Okay. After that, it should allow const now and eclipse tense like this. Okay. And after that, it should add the thing. This dot token will be minimized and last now. And process request is constantly. Okay. So yeah, we did the wrong thing. Let's correct it. Here this dot hashtag max token not let's also hashtag tokens will have a max token. Okay, and the first also initially they are max token. After that we have this dot hashtag last refill will we have a date dot now. Okay, after that we will be create a let now equals to date dot now. Done. Let's create now minus this and we are done with here. It's const electives seconds. It's happened many of the time because we didn't know how does the function works. This is the first time that we are practicing. So let's learn and understand how this the problem statement will be. We are learning here only. Okay, and this dot max token and this dot tokens plus tokens to add. That is the correct thing. And now we have to check the process. It doesn't need any refill things. Doesn't need this thing. And we will be doing is token less than minus return true, return true, else return false. Okay. Uh, but how the test cases and what will and how the test cases will be written in return for question 2. I just understand that too because I didn't understand. To test the token, your test case simulate algorithms. Okay. They here they have been mentioned. Mm, mm, created a MS new promise set timeout MS. Okay. Mm-hmm. Mm, rate limiter new rate limit 3. Testing request 1 await limit dot allow request true 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 expected false false exhausted. Okay, somewhat we have understood. Let's paste here and check. What we don't have to check is this thing. We have already completed this thing. Uh, error T is not defined. Testing T is not defined. Yeah, remove this T and now let's just see. Testing to capacity to testing waiting 1.3 second fully tested refueling back to buster. Okay, how does this they form this thing? I understand this thing. Okay, await radiant dot await expected true. Second testing consumption limit. We all use the consumption spam. We just try to call this thing. And here we are seeing the weight limit. Weight limit is 1200. What our waiting seconds? Okay, there's okay. Purposely have been added a 12-second weight limit allow request. Okay, so wait 3000. Bursted. Just see the output. Uh, true. But where is the false? I didn't see the one upon the false. Mm, yeah, these are the questions are too much little bit tricky and a complexity. You can see the first and true, and the 4 and 5 will the false. 4 and 5 is true. 4 and 5th is true. But why it is so? 4 and 5th is true. Let's just compare the thing. Uh, what to be true, return false. Mm-hmm, mm-hmm, mm-hmm. Okay, I didn't forgot to this thing. This dot hashtag last refill time stamp equals to date dot now, which means we have just updating the now. Okay, we don't have to do again and again. Just calling the now, it's enough. And now we are able to see the true, true, false. Let's check. Okay, false. Okay, one is the false, second is true, false, and after immediately. Okay, I think so. There is one more pending thing that we have been didn't tell you. We just tracked it. Created a variables privately, tokens, refill rate, max tokens. Okay, last refilling time stamps, date dot now. Okay, allow data now. Okay, minus with this, and eclipse multiply by this, and okay, watch it. Correct, correct. Mm-hmm. Mm, the token is greater than equals to minus 1. True, and it will be false. Okay, that's it. I think so. Yeah, false. True. Waiting was again true, 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 true. So these are the some of the complex level of a thing that we have to practice more and more so we can master it. So we have a one more structure, but so we have already practiced this, and this has a lot of a huge complications and complexity that we have to understand and practice more about. So we will be continuing this the third question in the next session and moving forward with more system design questions to practice it and understand and improve our session practice. Okay, that's it for our side today. Meet you in the next sessions. Till then, good night. Radhe Radhe.